It's go time? Did somebody say? It's go time. All right, that sounds way more cool than what is actually about to happen. Okay, so just in the room, who in the room would classify themselves as a .NET developer? Not everybody, but many of you. Do I have Java developers? I have one. Let's see what, Python. Ish, kinda, okay. Oh, you were waving at them. It's like, hey, I have one Python. Okay. Ruby. No. Okay, who would classify yourselves as a JavaScript developer? Okay, so now, interestingly enough, you didn't use, I saw some people raise their hand for multiple things. So .NET developer and JavaScript developer were becoming more and more right. Like, is anybody just a JavaScript developer? That's becoming more of a thing now as well, right? It used to be JavaScript was that thing that you used to make the browser do stuff. Like, hey, jQuery on click or, find. Now JavaScript has become like its own thing, and you've got React and Angular and all these other, although Angular's TypeScript, but who's, anybody React? I will make one React reference over the course of this entire talk. So if you don't get it, don't worry, I'll explain it. Angular? Okay. Excellent. So this talk is functional style JavaScript, a skeptic's guide, and I'll kind of talk about why I call it a skeptic's guide here in just a second. But if you have not heard the phrase functional JavaScript, you may have been living under a rock. I don't know if you've, like all of the cool kids, or would you agree with that? All the cool kids are doing functional JavaScript now, right? Nobody does regular JavaScript anymore. So here's the thing. I started my life as a Java developer, as a .NET developer. I'm now a JavaScript guy. I've got a Gang of Four design patterns course on Pluralsight. I don't do the functional thing, right? Like, I like my procedural OO kind of code. Functional is all weird and esoteric, and it doesn't necessarily make sense. And I would talk to people, the cool kids, if you will, and they would say something like, JavaScript is perfect for functional development because in JavaScript, functions are first-class objects. Have you heard this? Yeah, this makes it awesome, right? And I would say, no. It's right here in your phrase, right? Functions are first-class objects. Like we're still OO, we're still procedural, we're still normal, right? Don't go weird. We're still dealing with objects here. But I did what any normal person would do when confronted with something I didn't necessarily fully understand yet. What's the first thing you go to when you don't understand what something is? Wikipedia. It's not a trick question. So I went out to Wikipedia. And it says this. Let's walk through this for a second. This is Wikipedia's definition of functional style. This is not mine. In computer science, functional programming is a programming paradigm. I think we could all agree with that. Programming paradigm. Right, okay, I haven't lost any of you yet. I might lose you in a minute. A style of building the structure and elements of computer programs. This we'll talk about for the next hour. Don't worry, it's not all Wikipedia. Like, I'll get into code and we'll talk about stuff. It'll be fun. That treats computation as the evaluation of mathematical functions. In case you missed the important word there, math. Now, I don't know about you, but I started my life, so I went to college as a math major. We were on the quarter system, so my freshman year in college, I took Cal 1, I took Cal 2, I took Cal 3, and I said I don't ever want to do math again. So I became a computer science major after that because I didn't have to take any more math. Actually, what's funny, my senior year, I did need to take one more my Cal 3 professor was my college algebra professor my senior year. He didn't like me being in there. But I hate math. I hate math a lot. So I don't know if you guys are familiar. My daughter is now a sophomore, so she's 10th grade. I don't know how that translates to what you guys do. But she came home with math one day, and she was doing this. And I got really excited. I was like, oh no, this is functions. Like I write functions every day. She's like, I know, Dad, programming, shut up, this is math, right? It's not the same thing, but it is. And when we talk, this is what we're talking about. Okay, so f of x equals x plus 2. Everybody understand this. So if I pass a 3, so f of 3 plus 2, I get 5. Functional programming, that's what it comes down to. If you want to build a bunch of stuff that does this, you're in the right place. You're doing the right thing. And then we have this nugget to round it out, and avoids changing state and mutable data. So I don't know if you guys are familiar with the programming language that we are talking about. Nothing's immutable in Java. Like, everything has changed. The core object isn't even immutable. You can go in and mess around. Try this sometime. I was going to say, don't try this sometime. Just go, like, change function. You can. That's how Track.js actually does a lot of the stuff they do, is they add stuff into functions and objects and track everything that's going on. So, yeah. Okay. That is why this talk is not called functional JavaScript. I do not believe as a person that functional JavaScript really exists. There are some packages that help. We're going to talk about functional style JavaScript, because there are, so as much as I've kind of like laughed at some of it, you can learn a lot and you can do a lot of things with the functional style, and we'll dig into what that kind of means. So, Martin Odersky says this: the programmers in that segment being functional programming, like functional programming because it makes code cleaner, better structured, and prevents many classes of errors. Overall, according to Martin, functional programming is just better. It's better than whatever you're doing now because it's cleaner, it's better structured, and the errors don't happen. That's fair. So you might hear things like the following. Okay, so I have a friend I would go out to lunch with. He would talk through, and he would say, I kid you not, he would utter this phrase. This is a real conversation. He said, man, when you can take a function and you can strip it down and make it just a pure function, that's the best feeling. Now, I'm sad for him because I don't think he understands what the word best means. But, and I would say, in response, pure functions are awesome. Why? It's in the name. They're pure. They're beautiful, right? It's like, but why? I don't know. They're testable. I mean, that's usually about as far as I got. And so we'll talk about that. We'll come back to it. Side effects. Your code should have no side effects. Have you heard this phrase before? No side effects. How many of you have ever wanted to like output something to a screen or like do a network call? Or guess what? Those are all side effects. So side effects have to happen. Like you can't not do side effects. That's craziness. But all of my friends anyway, they say all these things, but they didn't ever understand why. And if you don't know what tail recursion is, good. You may look that up later if you want to. I'm not going to talk about it, but right, it's one of those things that just you don't need to worry about. Okay, but it comes back to this. Here's the key to Martin's talk or comment. Prevents many classes of errors. Here's the thing with functional programming. they have compilers and they have tools that like prevent all this stuff from happening. In JavaScript, we don't have all those tools. So we don't have anything that makes sure you didn't change state, and we don't have anything that makes sure your functions are pure. We just have to kind of do it on our own, and it doesn't actually prevent hardcore the errors that it thinks it does. So there you go, we're done. Don't do it, right? No, I promise, that's not what okay. So I was talking to this guy named Nate Taylor. This is his Twitter handle, and so every time I do this talk, somebody tweets at him and lets him know that I'm doing this talk. Nate Taylor is so famous. I don't know, any Pluralsight people? Okay, he has his own Pluralsight icon in the icon library at Pluralsight. Like, this is actually what Nate Taylor looks like. Nate Taylor has a functional JavaScript course. And so before that course came out, we were talking a little bit, and I was kind of expressing my frustrations with the whole functional thing. And Nate did what he does best, is he told me I was wrong. And that we need to figure this out. And so he said, here's the reality. In JavaScript, remember, we're not talking about Scala or Elm or any of these other things. We're talking about JavaScript. In JavaScript, functional style is not about the error part of it. It's about the other two things. So in JavaScript, right, you can't avoid all your side effects. Side effects are going to happen. You have to have side effects. Those are things that happen. Not all of your functions are going to be pure. That's not the point. The point is about, not everything has to be immutable. Or nothing can be immutable. Yeah, you want to have some things not change, but not everything has to be immutable. Here's the thing. We're going to spend the rest of the time, I'm going to convince you of this thing. Using functional style in JavaScript is about making your life easier, not harder. It's about simplifying what we're doing so that we're using less brain power, right, and making things simpler. So this is ultimately the point. Functional JavaScript is about building small composable things and fitting them together to make the big overarching. Right, so back to the example, right? It's about building the elements. Structuring the, so we're gonna talk about this for the rest of the talk. Okay, how many of you have seen this map before? I will tell you, Europe at night is very different than America at night, because in America, like from here over, it's black. Like nobody lives out there except for right along the coast. In Europe, like you guys live everywhere. Like even in the middle of the ocean, there's still people. I don't necessarily understand. I guess there's islands all through here. I don't know.
Oil rigs.
Are they oil rigs? Is that what it is? Okay. That makes a lot of sense. Thank you. Yay. Okay. Even like way up here. Anyway, okay. Are those oil rigs too? Is that? You guys love your oil. Okay. I guess that makes a lot more sense. Anyway, beside the point. So, this is how I tend to think of programming. And you know, I'm an architect, I'm a technology advisor. I think about systems. I think about the big picture and how everything fits together and all of this stuff. But guess what? This doesn't just happen. Right? Nobody thought at the beginning, hey, here's Europe. Let's make lots of lights here. Right? This kind of came about. There was some planning involved, but it just kind of came about. It's a whole lot of these. It's a lot of these, and apparently a lot of fires from oil rigs. But there's also these. And so this is the stuff we're going to talk about. Because ultimately, this is the stuff that your code's made of. You're going to make a whole lot of streetlights that are going to end up being that big, huge map. So, functional style for us, what we're going to talk about here, thinks about the smallest pieces and how to fit those things together. Let's start, Because ultimately you have to think about both, right? So when we start doing functional style, it doesn't mean ignore everything else. You still have to think about the big picture and think about the procedure and think about all of those things. But when it comes time to actually start building things together, let's look at arrays. The subtitle for this talk used to be, never write a for loop again. Because how many of you write a for loop? How many of you wrote a for loop like yesterday? I know it was Sunday, but still. Like for loops are the default, like literally I used to joke that our entire job as a developer was getting data from somewhere, putting it in a for loop and doing stuff with it, and then displaying it to a screen. Like that sums up what we do, right? So let's look at arrays and we'll kind of set the stage for some simplicity here because this becomes really easy in JavaScript. All right. What's the output of this loop? Okay, you guys, I assume, have been doing programming at least for a little while. And it took you more, I waited like a good 15 seconds. And nobody belted out any, anybody want to take a guess? It's not a trick question. This is not a trick.
2, 3, 4, 5, 6.
2, 3, 4, 5, 6. Excellent. Right. We're just going to add 1 to each item. The first couple of times I did this talk, I left this comment here, and like everybody got it right away. But once you have to kind of think about it, this is about as simple a for loop I could come up with. And it still takes a little bit of time to figure out what's going on. I mean, let's kind of break this down. We've got some iteration code that's going on here. You know, how we're going to iterate over a thing. I'm certain that you will have examples, but almost never do I have anything other than I++ here. Right? Give me the next one. Right? But now you've got for each, and you've got all these other things that essentially kind of do this for you, but it's still kind of the basic idea. And then we have some worker code. Here's some code that we're going to implement on each item. That's how for loops break down. Okay, so I have multiple things that are happening, not just one, and I want to break everything apart. Functional style says let's take it to the minimum possible thing I can take it to. So let's break this up. Okay, so let's take our iteration code. How many of you, I'm starting with the one that's easy because many of you will know this. List.map. What does list.map do? It iterates over the array, right? It basically is the for loop, but broken down into just this one thing. But then list.map takes a function. So what were we doing? What were we doing in the array? To the array. Each item in the array, what were we doing to it? Do you remember?
Adding 1.
We're adding 1. Right? We just got, let's do a +1 right there. So what we need to do with map is we need to pass a function into list.map to do the thing. But it has to be a pure function. It doesn't have to be because nothing is enforced, but please make it a pure function, right? And so what is a pure function? Let's talk about what the definition of a pure function is. In computer programming, I don't know another paradigm where we talk about pure functions, but a function may be considered a pure function if both must have both things of the following statements hold true. The function always evaluates to the same result given the same arguments as values. It is very predictable. Pass one thing in, you get the same thing back. Remember this? If I pass 3 into here, I will always get 5. It's actually kind of funny. I had my 3 + 2 = 5 slide up, and a friend of mine was like, well, that's good to know. I was like, no, that's the point. Like, you know you will always have 5. You will never get 7. You'll never get 10. You know. Function AB return AB. Always returns the same thing. That is a pure function. Math.random. Not pure. Will you ever have to do random numbers? Yes. Guess what? You're not going to do them with a pure function. Evaluation of the results, here's the second thing. Does not cause any semantically observable side effect or output, such as mutations of mutable objects or output to I/O devices. A pure function can't change anything else. And that's important, and here's why. Well, hold on. So how many of you have had to like sum things before, right? I'm doing something outside, not a pure function. Okay, why? Anybody take a wild guess? Why would you have pure functions?
More easily testable.
More easily testable. What else? Functional style, we're making things simple. So if they're pure, and I can rely on it always being the same thing, it's less complex, easier to reason about. I understand what this piece of code is doing. Easier to test, right? How many of you write unit tests for your code? How many of you sometimes think that is a very hard thing to do? Right. Simplify it a little bit. Write your code in a way that's much easier to test, and pure functions help with that. Because there's less complexity, because it's easier to test, it becomes much easier to understand. We want to use less brain power overall of the whole thing. All right, so I now have a function that says, hey, I'm going to return +1. Throw that in there. This is, however, now 2019. We don't do things like this anymore. Now we do it like this, arrow functions. We're not going to talk about arrow functions, but like we tend to do that for anonymous functions now. And then depending on where you're working, I actually have worked at a place where this would fail a code review, because I did several unnecessary keystrokes. Right, here I can just do this. I don't necessarily like this, but I went along with it because it becomes a little harder to read. So this is simple. Now I have one rule in life. And yes, this is a very simplistic example. We don't tend to do this. Most of the stuff we do is a little more complicated. I have a general rule in life is I do not like anonymous functions. As a rule, anonymous functions can be unclear. What if I pulled this out and gave it a name? What? So now I just pull the list.map, add 1. Okay, remember this was supposed to be easier to understand and clearer. Do you remember this? And I said, hey, what's going to be the output here? And I waited about 15 seconds for you guys to figure this out. And some of you got it right away. I know you just didn't want to say it out loud, right? But we went from this to this. What's gonna print out to the console? I'm not going to call on you because you know the right answer. I'm going to assume. Okay, what's going to print out to the console? Go ahead and say it.
Same as what's at the top, 1, 2, 3.
Right, okay, yeah. There we go. And there's a reason for that, and we'll get to that here in just a second. But the idea here is this line is incredibly easy to understand. It takes no brain power, it takes no time. List.map, add 1. I'm adding 1 to each item, because inside map happens to each item, so I'm just adding 1. But we have another rule in functional programming, which is immutability, right? So avoids changing state in mutable data. So I'm not going to have a function that's going to change the contents of the thing that's happening. Because honestly, why force it? So if list.map always changed what was happening in list, what happens if I want list? It's not really all that simple to make a copy of something. I mean, you've got to like call, you can't just say list B equals list A and then change list A. It doesn't work that way. Right, but I can do this. I can just say const new list equals. And now I have both my list and my new list, and things are changed. I have that option that's available to me. What if I want to change list, though? Can I do that? Yeah, I just say list equals. This is like not rockstar stuff, right? So overall, this code is significantly easier than it was before. Is map the only option? Dude, why immutability? Okay, React. Here's your React example for those of you who do React. How does React know when state has changed? It just compares the old state to the new state. If they're the same, they haven't changed. If they're different, it's changed. It's super easy. If you change something, if I go object A dot X equals something, it's still the same object. It hasn't changed. If I say object or state equals something else, then I change it. If I don't, okay. This is just a pointer evaluation, right? It's not a make sure everything's the same. If they're pointing to the same thing, it's the same thing. If this is different, guess what? Things are changed. It enforces options. We talked about that. And again, it's easier to understand. If you have to worry about whether or not something changed, that's one more thing you've got to think about. Because ultimately, we want to make things easier. This one line, this is what you're walking away from. And no for loops. Like, this is the whole point of what we're trying to accomplish. But I used an incredibly simple, like way simple example. How often do you just add one to things in a list and then, right, things become much more complicated. So let's talk about that. Remember when we did the sum thing? Like not everything is self-contained. Sometimes you have to do things outside. There's a function for this. There's an array function called reduce. And so what reduce does is it's the same thing as the map. It's going to run on everything, but it's going to pass in a value. That starts with 0 here. And so I've got, here's the item, and here's my running total, my running sum. And then I'm just going to add the item to the sum, and then at the end, it's going to spit that out. So what's happening? List.reduce, what am I doing? I'm summing my list. That's it. You don't have to read the code and figure out what's going on. Hey, guess what? I'm summing my list. So you use reduce to do things like calculations across an array. What is this line of code doing? It's returning. Right, so it's returning all the even numbers. That's it, right? Simple. Very easy to understand. Here's what this looks like, right? So I have a list.filter is going to filter stuff, and anything that is even. So that's ultimately what that means. Item 2, if there's no remainder, then it's false, so I have to not it to make it true. List.filter is even. Okay. And because we're returning new, I can chain them. And I can do map reduce. I'm going to add one and then sum. Right? Just like now we're back into jQuery days. Who remembers jQuery? Like you can chain everything. Oh, yeah, right? Okay, so I can chain everything that I need. I like jQuery. I haven't done jQuery in a very long time, but I just remember it was all so awesome that I could just like chain all this stuff out. Okay, we're going to talk about the last concept now when it comes to this. So I've got a list of names. John, Jack, Mary, Susan, Sarah. And I want to find Mary in this list, right? So I'm going to do this, list.find. And I'm going to check every item to see if it's Mary. I should probably, if I hadn't pointed that out, nobody would have noticed. I need to fix that. Okay, so find list.Mary, or find Mary from the list, right? here's a problem with this. First of all, I have one rule in life, which means I don't like anonymous functions. So I need to pull this out. So this works, but what happens when I want to find something else? I have to create a new function that has Susan in it instead of Mary, and none of that works. So we're going to do something a little different. I want to do this. I want to pass in who I'm looking for into my get person, and then it's going to go find that. List.find does not accept that, by the way. So I got to figure something else out. So let's talk about higher order functions. How many of you are familiar with the phrase higher order functions? It's really simple. There's a lot of words here. But it's really simple. It is a function that does at least one of the following. Remember, pure functions had to do both. Higher order functions only have to do one. It either takes one or more functions as an argument. Think about a callback, right? I'm passing a function into a callback. That's a higher order function. It takes a function as an argument, and then it's going to execute it later. Or it returns a function as its result. So you can write a function that returns another function, and then that function is what gets executed. So think about that. Here's what I want. So getPerson actually is going to return a function with the search term. So right, I'm going to call getPerson Mary. I fixed it. See, magic. Okay, so return function. I get excited about the dumbest things. Okay. And now I'm going to return a function that searches for Mary. So you can say, hey, I need a function that does this thing, and you can create a function that's going to build that function, it's going to return the function, it's going to do all this kind of stuff. You could do this, but I hate that. It's the same thing. On its face, does that make sense to anybody, right? I mean, so we get carried away with our arrow functions sometimes. But I originally had it like that. I was like, that makes it way more horrible. This search returns this, which is a function which returns that. Okay. Oh, right. So getPerson Mary, what's it going to return? It's going to just return Mary, and you already have Mary, so you don't need Mary, right? That doesn't help you at all. So in this particular, usually you're looking for an object, and then you'll do something on the, right? In this case, no, so we have find index, which will also do this. Now, those are the array things I'm going to talk about. And so what I would encourage you to do is the next time you find yourself having to write a for loop and look for something, look at the list of functions that are attached to array. There is something already written that's going to do what you're trying to accomplish. And the end result of the code is going to be so much cleaner than whatever for loop you're going to be implementing. It's just adopting the functional style is starting to get your mind into this, what's the function I can call to do this, instead of what's the code I need to write to do this. Currying. Okay, so we had Indian food last night, and so now that's, of course, all I can think of when I say currying is more Indian food. Okay, so currying. How many of you have heard this term? Okay. Currying is this. In mathematics and computer science, in both, not just computer science, currying is the technique of translating the evaluation of a function that takes multiple arguments into evaluation of a sequence of functions with a single argument. Sounds pretty straightforward, right? We, my friends, are going to take this function, and we're going to turn it into this. Right? Like, that's what it is. That doesn't really even... well, It doesn't even make sense. Like if I need 2 arguments, just let me take 2 arguments. Why do I have to make things complicated by like breaking things out? It's just weird. So I'm going to give you an example, and this is just an example, but it's the mindset that we're going to start adopting when it comes to functional style and currying. Okay, so I have 3 buttons, and those 3 buttons have 3 different messages. And depending on the button that's being clicked, I want to display the message. It's contrived, I know, but we're going to make a point. So if I click on button 3, what message do I want to click or display? Simple, easy? Button 3, okay. So an on-click event handler takes an event. And then I'm going to take the ID, or I'm going to loop over the buttons to figure out what message I'm supposed to display. What I really want is I want the index as well. If the click handler could pass me the button index, I wouldn't have to go look for the button. I could just go straight to the button. And that would be so much easier. The problem is the click handler doesn't work this way, right? It only passes me the event. And so look at what we have here. We have a function that takes 2 parameters. What if I could take this function that takes 2 parameters, right, and separate it into a series of functions that each take 1? That's currying, right? So what we can do, remember this too? So we needed find to take Mary as well, so we kind of broke it out. We're going to do the same thing. I can do this. I can create a function that takes index. And that function that takes index returns a function that takes event. Index and event. We used to be 1 function that takes 2. Now I have 2 functions that take 1. And then I can use, what's the word? I can use the index that was passed in to pass. Now, where does index come from? From the closure of the function, right? So closures basically mean this function right here, function event, has access to the larger scope when it was created. So this index flows through from the same place. So basically what I could do is I could say, hey, get on click index from my click event handler. And it's done, right? So that's currying. Basically, don't think about it as execution right next to each other. Think about it as execution so I can ship it to different parts of the system. This part of the system is going to do this thing, this part is going to do this thing, so I can pull everything apart into 2 separate things. Monads. Who could explain to me what a monad is? Nobody. No, he cannot. So this is real. Crockford has a law that says once you understand monads, you can no longer explain monads to someone else. And there's much more to the law than this. This is, so monads are hard. And actually what the longer version of the law kind of states is, you're going to take a lot of time, you're going to understand monads, you're going to think they're awesome. Like you're going to dig in and like, these things are life-altering. They're going to change everything about everything. And then you're going to try and explain it to somebody. And what they're going to think is, yeah, that's kind of stupid. So I'm going to attempt to prove that, I guess, out. Because I'm going to explain monads to you. And then you're going to say, well, that doesn't make sense. And then we'll talk a little bit more about that. Okay, so. More Wikipedia. In functional programming, a monad is a design pattern. First of all, that's the most important thing. This is a pattern. that defines how functions, actions, inputs, and outputs can be used together to build generic types. Think about this for, okay, hold on. I have functions, inputs, and outputs joined together into one type. What is that called? That's an object, right? So, okay, anyway, sorry. I have functions, actions, inputs, and outputs that can be built together to form a generic type with the following organization. 1, define a data type and how values of that data type are combined. Here's a type, and here's how this stuff works together. And 2, create functions that use said data type and compose them together into actions, following the rules. So basically a monad is, if you're a functional person, like you would throw a tomato at me right now. So I get that. Functions are basically like objects that do stuff, right? But way more complicated than that, but not really. Monads are things, and so in functional, like Scala or like real functional programming, you can't change things, things are immutable, there's all this big thing. Monads are this big implementation that allow you to get around that. That's kind of the point at a much higher level. But let me explain this. Okay, this is an actual monad. It is the simplest monad, but it is an actual monad. This is the identity monad. The identity monad is a function called identity, and you're going to pass a value, and then the value of said identity is the value. So if I pass 5 in, what's the value of the identity monad? 5. Now this is a constructor. You can't call this over and over again. This is when you construct the identity. This is what it is. I pass in a 5, I get a 5 back. All right, now we add a function called bind on the prototype of it. So on the object that passes in a transformed value, and it's going to return transform of that value. Ultimately, what you end up with is something like this: x.bind value, and it returns a new identity with 2 added to the value. So basically, every time you change something on a monad, you are creating a new thing and passing the new thing back. Why? Because things are immutable, right? This becomes complicated. We'll get back, hold on, I'll come back to that in a second. Okay, well, no, actually, I'll talk about this while I have this slide up, because this slide is not necessarily true. For you, in general, when somebody starts saying, hey, you should turn that into a monad, not that you'll ever hear that. If you do, then you have, your response to them is, I don't think so. That doesn't seem like the best use of our time right now. Now, that does not mean monads do not exist in JavaScript or do not have use in JavaScript. One example that I like is, how many of you use a promise? A promise is an implementation of a particular type of monad. I mean, monads exist, and they exist down in the framework and tools to make things a little bit easier. We generally are not the people who are writing the promise framework, right? We're implementing the promise framework. So we don't have to worry about this so much. And here's the other problem with the monad. Remember this phrase, prevents many classes of errors. It's the tooling that does the work. So here I have a monad, 5, I do a bind with a new identity value plus 2, I get an 8. The value of my monad is 8, and I know that, and it's clear right up until somebody does this. Because can I stop that in any way ever? No. It doesn't work. So that's the struggle when you start building and implementing the big monolithic things in JavaScript. Sometimes you get, careless. Okay. Because ultimately, for the majority of it, it's the tooling that does the work. So here's the thing that I want you to walk away with. Because functional style for you in JavaScript, for me, makes a lot of sense. Because it's not the big picture always. Sometimes it's just the little picture. And so ultimately, the next time you sit down, so when you go back to work Monday, I guess, because you're here all week. Maybe not. Anyway, Monday, you're going to go back to work, and you're going to sit down and you're going to start writing a for loop for something. And I want you to think out loud to yourself and all of your coworkers, this is not the simplest way to solve this problem. There's a much simpler way to solve this problem by doing something with the array object. There's a function on the array prototype that's going to make this simpler for me. We're going to write a pure function. We're going to pass it in. This is going to be much more readable when we're done. Simplify your pieces. Remember that things are composable. Keep your interactions simple. Remember that functions are things you can pass around. I can create a function, I can pass it over here, and something gets done over here. And then I can do something over there, it's going to return a function over here. Functions are things you can pass around, but keep your interactions simple because you want to be able to think about them later. Because ultimately, this is the point. Functional style is about using less brain power. Like, seriously, what we do is not like super easy, right? We want to be as easy as we can. And that's where the functional style really steps in, is let's make things simple and readable so we can get things done. All right. Questions? Thoughts? If you don't have any, you are free to go. Yes?
I just wondered what your thoughts are on sort of immutable JS.
Okay. Thank you. That was the other thing I was going to mention, and I didn't. Okay, so there are a couple of tools that you can use to help implement this. So Ramda, who's heard of that? Right, so do you like it? Is it good? I like it. I mean, it seems to help with it. So it's got some of this baked in. So that's a good resource for you. Immutable JS is something that helps make things immutable. Like it helps with this process. So it gives you a level of tooling that's going to make that work for you. It's not infallible, but it is helpful. So there's a couple of tools, Ramda and Immutable JS, that are going to help you implement kind of these concepts. All right, thank you guys very much. Enjoy the rest of the show, and you can catch me around if you want to chat more. All right, thank you guys.